You may have heard the word ether or ether kicking around in certain New Age or metaphysical circles, but did you know it was once a cornerstone of mainstream science? And I'm talking about something much vaster and deeper than just space. Programs like the Apollo missions were predicated on this theory. There was even an Aether commission established by the US Congress to research it. So what the heck is the Aether, and why don't we learn about it anymore? Let's start with a brief history lesson. The word ether was first used by the ancient Greek philosophers, most notably Aristotle, who believed everything was composed of four elements: fire, water, earth, and air. However, he noted that there had to be a fifth element, something pure and unchanging, which he called ether, to fill the heavens above the terrestrial realm. Ether was literally translated from the Greek as upper, pure air, according to Aristotle. Fast forward to the 1800s, we find that scientists had settled on the idea that light was made of waves. Now we know that waves like sound need a medium to travel through. You can't hear anything if you're in a vacuum like outer space. So scientists figured light must need a medium too. Otherwise, how could it travel through the vacuum of space? They knew there was some sort of medium permeating all of space since it was impossible to hear sounds on the moon. Thus, the prevailing theory was that the entire universe was filled with a substance that would carry light waves, electricity, and even other forms of energy. This became known as the luminiferous ether, or simply the ether. In fact, physicists at the time believed there were two versions of ether. One was tied to electromagnetism, and another was needed for mechanics. This field of study was very popular at the time, and many prominent scientists were involved, including Michael Faraday, James Clerk Maxwell, and Albert A. Michelson. In 1887, Albert Michelson and Edward Morley performed an experiment to measure the speed of light in different directions to determine if the Earth's movement through the ether could be detected. If you can imagine a boat traveling through water, you might expect it to move faster with the current and slower against the current. Similarly, the Michelson-Morley experiment expected the speed of light to change depending on the direction it traveled relative to the Earth's movement through the supposed luminiferous ether. But they found no difference in the speed of light no matter the direction. This experiment would come to be known as the null result. For years, scientists were baffled by the null results. They began to hypothesize that maybe the ether was stationary and it was actually the Earth that was moving through it. Or maybe the ether was moving with the Earth, perhaps even carried along by some sort of cosmic